Hello everyone, welcome back to Blocking the Flame, Anakinra and COVID. I'm your host Gaganasri, a computational biology enthusiast. Today we are stepping into a molecular crossroads, a place where the immune system shakes hands and sometimes locks horns with metabolism. It's a story of inflammation, disruption, and the possibility of repair. To help us untangle this intricate dance, I'm joined by Aseema, a passionate microbiologist with a strong foundation in biotech and emerging interest in the gut-brain axis, where immunity, metabolism, and the mind converge. Aseema, it's a pleasure to have you with us.
Thank you so much, Gaganasri. I'm really excited to be here as always. And this intersection of immunity and metabolism really fascinates me, I must say, especially because it doesn't just affect one system, it impacts how our entire body copes with both acute infections and long-term changes as well. So it's a window into the deeper ripple effects of diseases like COVID-19.
Beautifully said. Let's begin by unpacking the term immunometabolism. For many of our listeners, this might sound like the merging of two entirely different fields. How would you define immunometabolism and how does it relate to COVID-19?
Oh, great question. So, immunometabolism is like the power grid of our immune system, I would say. How energy is produced, distributed, and consumed by the immune cells during different states like rest, activation, or repair. So, in simple terms, it looks at the two-way conversation between immune cells and metabolic pathways. When you're sick, say with COVID-19, your immune system gears up like a city that is under siege, and it demands a huge amount of energy and resources. But if that response is too strong or lasts too long, it can cause systemic disruptions. COVID-19 is quite notorious for triggering what's known as a cytokine storm, which is a hyperactive immune response. In this storm, IL-1, which is a key inflammatory cytokine, plays a very pivotal role. It disrupts the normal metabolic processes, causing things like insulin resistance, lipid imbalances, and fatigue, which we now recognize in many COVID-19 and long COVID patients.
That's a vivid picture. An immune city drawing power from every reserve until the lights start flickering. Let's zoom in on IL-1, this molecular troublemaker. How exactly IL-1, which we have already discussed many times, interfere with metabolism, especially in the context of COVID-19?
IL-1, as we know, is like the fire alarm in the immune system. It gets triggered early and loudly to signal that something is wrong. While it helps initiate protective responses, excessive IL-1 can essentially keep the alarm blaring even when the threat is gone. And here's how IL-1 disrupts the metabolic harmony, like insulin resistance, where IL-1 interferes with insulin signaling in key tissues like the liver and muscles, which leads to insulin resistance, where cells can't absorb glucose efficiently, causing the blood sugar levels to spike, which is an effect we see in both diabetic as well as non diabetic COVID patients. Then comes lipid dysregulation, where it alters fat metabolism by promoting lipolysis and inhibiting lipid clearance, leading to accumulation of fatty acids and even ectopic fat in organs like the liver. There's also energy imbalance where chronic IL-1 signaling hijacks energy resources, increasing the energy expenditure inefficiently. And this leaves patients feeling constantly drained, something often reported in long COVID. So, IL-1 doesn't just fan the flames of inflammation, it also derails our metabolic machinery, turning the efficient systems into erratic ones.
That paints a compelling case for why IL-1 is such a central figure. It's not just sounding the alarm, it's messing with the wiring. Now, this brings us to Anakinra, a molecule designed to silence IL-1's excessive noise. What do we know about Anakinra's role in addressing these metabolic disruptions?
So Anakinra basically acts like a noise cancelling device, I would say. It binds to the IL-1 receptor and blocks IL-1 from exerting its effects. And in doing so, it may restore balance in several ways. For example, restoring insulin sensitivity by reducing IL-1's interference. And insulin signaling can improve here, which helps bring the glucose levels back under control. There's early evidence from non COVID contexts like type 2 diabetes where Anakinra has improved the glycemic markers. It also helps by normalizing lipid metabolism, where lowering inflammation helps the liver process fats more efficiently, which can prevent fatty liver disease and other metabolic syndromes often exacerbated by viral infections. It reduces fatigue as well by dialing down systemic inflammation. Energy usage becomes more regulated, possibly reducing the fatigue that lingers post infection. So, while anakinra's primary role is anti inflammatory, its secondary effect on metabolism are both intriguing as well as promising.
It's like treating the flame but ending up fixing the smoke damage too. Still, I imagine we are only scratching the surface here. What are the main challenges in applying Anakinra, especially for metabolic dysfunction in COVID-19?
Absolutely. So the biggest challenge is that IL-1 doesn't act alone. It's a part of a network. Think of it like trying to calm a riot by silencing just one voice in a loud crowd. While helpful, it might not be always sufficient. And also, other issues include timing, where administering Anakinra too late might miss the window where it could prevent metabolic dysfunction. Similarly, too early, it might interfere with necessary immune responses as well. Variability also matters. Different patients exhibit different inflammatory profiles. Some may benefit a lot from the IL-1 inhibition, while others may need a broader or entirely different approach. And in case of long COVID, the lingering inflammation that is seen could respond differently to IL-1 blockade compared to acute infection. So we don't know yet how Anakinra performs over long timelines. It's a promising tool, but it's not the whole toolbox. We need a targeted research to understand where it fits the best.
That's a thoughtful reflection. It seems like we are at the edge of a map. Some trails have been drawn, but most remain unexplored. So, Asima, what are the next steps to push this frontier forward?
Well, of course, we need rigorous clinical trials that specifically track metabolic markers alongside inflammatory ones, both during acute infection and in the months after recovery as well. It's also time to look at combination therapies. Anakinra might be more effective when paired with metabolic agents like metformin or with other cytokine inhibitors. And finally, from a systems biology perspective, we need to start profiling patients, understanding who is most at risk of immunometabolic disruption and personalizing interventions. This will be crucial not just for COVID 19, but also for future pandemics or chronic inflammatory diseases that may affect metabolism.
That sounds like a rich roadmap. I love how you framed it. Not just treating the fire, but learning to predict and prevent the storm. Thank you so much, Asima, for joining us today. Your insights really brought the complex world of immunometabolism to life.
Thank you so much, Gaganasri. It was a real pleasure to share this space with you and talk about something that bridges so many disciplines and holds so much potential for improving lives.
In our next episode, we'll shift gears to explore the safety and risk management of anakinra in COVID-19 patients. What do we know, and what should clinicians and patients be mindful of? Until then, thank you for all listening to Blocking the Flame, Anakinra, and COVID. Keep asking questions and stay curious.